When automotive engineers first heard about Tesla's plans, many of them just brushed it off. One press instead of hundreds of welded parts. Impossible. But while competitors were skeptically shaking their heads, Tesla was quietly rewriting the rules of automotive manufacturing. And by the time the industry realized it, there was almost no one left to catch up to. And now the company is getting ready to take the next step, one so radical that even those who had already accepted the Giga press as the new normal were caught off guard all over again. By the end of 2025, Tesla's Fremont production line was running with more than 1,000 robotic arms, welding, painting, assembling. A high-tech factory in every sense of the word, it seemed. But in early 2026, Tesla pulled half of those robots off the line, not because production had slowed down, but because something fundamentally different had taken their place. Elon Musk said it plainly: Tesla now has a car manufacturing system that has no equivalent anywhere in the world, and at the heart of that system is the fourth-generation Giga press. A machine that Musk had spent years developing specifically for new models, including the Cybercab robotaxi, a machine with the greatest casting force ever created, operating at a speed that looks more like consumer electronics assembly than a traditional auto plant. But a logical question comes up here. Why do you need an even bigger press when the new cars are compact? What's the logic? To understand that, you have to start from the very beginning. The story of the Giga press has its roots in the development of the Model Y. Tesla had an idea: strip out hundreds of welded parts and replace them with a single massive aluminum casting. The problem was that a machine capable of doing that simply didn't exist. Musk reached out to the world's leading manufacturers of casting equipment. Nobody could offer what was needed. Nobody, except one Italian manufacturer by the name of Idra, which at that moment was just finishing development of a giant high-pressure press. The timing turned out to be decisive. That's how the Giga press was born, the machine that today produces the largest structural components for models like the Model Y and the Cybertruck. Here's how it works. An aluminum alloy is melted in a massive furnace at extremely high temperatures. Then the liquid metal is injected under enormous pressure into a steel die that reproduces the exact geometry of the part. The pressure drives the molten metal into every microscopic corner of the mold, eliminating voids, weak spots, and defects. Once the mold is filled, cooling begins, and that's where all the technological significance lies. Inject the metal too fast and air bubbles form inside, weakening the part. Too slow and the aluminum starts to solidify before it fully fills the mold, and the casting is scrapped. That's why the cooling system is designed to maintain a uniform temperature throughout the entire process. Once the casting is complete, robotic systems extract the part, trim the excess metal, and send the component to quality control. The result isn't just faster production. By replacing dozens of welded elements with a single casting, the Giga press makes the car lighter, stronger, and more rigid, while simultaneously cutting production time, assembly complexity, and the need for manual labor. Today, Giga casting is no longer Tesla's exclusive. General Motors, Hyundai, Volvo, and Chinese manufacturers are pouring billions into their own casting systems. One Chinese manufacturer has already invested in a 16,000-ton machine. But while everyone else is trying to catch up to Tesla, the company is getting ready to leap so far ahead that the entire industry may be forced to rethink what's even possible. Musk's next target is a 50,000-ton Giga press. When he first put that number out there, the initial reaction was predictable. How can a machine that size even exist? Where would you put it? How long would installation take? And most importantly, how can a single press simultaneously produce structural components for 5 different cars at once? According to Musk, that's exactly the point. Once the 50,000-ton press is up and running, the factory will move at a speed that a human being physically cannot keep track of. Every stage, injecting the molten aluminum, cooling the mold, extracting the finished casting, will be carried out in a fully automated mode without any stops. One production cycle will take about 5 seconds. the frame of an entire car, in the time it takes you to blink a few times. Musk described it this way: the line will move so fast that people physically won't be able to get near it. This isn't a car factory in the traditional sense. This is consumer electronics manufacturing, except instead of smartphones, car frames are coming off the line. The basic principle of the 50,000-ton press is similar to previous versions. The difference is in the scale and precision of every single step. Aluminum, both primary and recycled from previous castings, is loaded into the furnace and melted at around 850 degrees Celsius. After surface impurities are removed, the liquid metal travels through heated pipelines into a second sealed holding furnace, where it's kept in the range of 750 to 850 degrees, always ready for the next cycle. The space inside the holding furnace is filled with nitrogen. This prevents the molten aluminum from reacting with oxygen and forming unwanted oxides. For additional purification, argon, a rotary degasser, and a silicon carbide filter are used to remove dissolved gases and particles larger than 25 microns. Only after all of that is the metal considered ready. Before each casting cycle, the mold is coated with a thin layer of lubricant. A robotic arm applies about 35 milliliters of soybean oil evenly across the entire surface, so the finished part releases cleanly. Then, a vacuum is created to remove air, after which the molten aluminum flows into the injection chamber. A plunger, lubricated with about 8 milliliters of oil before each shot, drives the metal into the mold cavity with tremendous force. After injection, the metal solidifies inside the mold, and the red-hot casting is extracted at a temperature of around 400 degrees Celsius. It's immediately submerged in a cooling bath, where the temperature drops to about 50 degrees. This isn't just about speeding up the process. Rapid cooling eliminates a number of casting defects and improves the mechanical properties of the material. The mold, meanwhile, cools down to around 185 degrees, after which a robotic system cleans every surface of it. The next cycle can begin in as little as 1 to 2 minutes. Excess aluminum is sent back to the melting furnace. Every finished casting goes through X-ray inspection to check its internal structure. Achieving that kind of speed isn't just a matter of building a bigger machine. Tesla developed an ultra-fast cooling system, an intelligent mold release mechanism, and an AI-based quality control system capable of inspecting every casting in real time. That combination of technologies had never existed in the automotive industry before. And here's where the story gets even more interesting. The 50,000-ton Giga press isn't just a new way to make cars, it's a reimagining of how factories operate. For the first time, automotive manufacturing is starting to look like the world of consumer electronics, highly automated, incredibly fast, compact, and built to maximize the use of every square foot of floor space. A telling example, while the Model Y had around 200 major structural components, the Cybercab has about 80. This isn't an evolution of manufacturing, it's a complete ground-up redesign. For more than a century, cars were assembled from hundreds of individual parts connected by welds, bolts, brackets, and rivets. Every one of those joints is a potential point of metal fatigue or long-term wear. Tesla is going in the opposite direction. A significant portion of the Cybercab's structure is meant to exist as a single monolithic casting. The advantages go far beyond simplifying production. A more unified structure provides greater rigidity, eliminates numerous potential failure points, and allows the chassis to behave as one continuous element rather than a collection of connected pieces. That delivers real-world benefits, from improved ride comfort and handling to more predictable energy absorption in a crash. And in a future where cars need to drive themselves, that kind of structural uniformity could become one of the key engineering advantages. But Tesla isn't stopping at the Giga press. The next bottleneck the company has in its sights is the paint shop. Painting a car is one of the most expensive, energy-intensive, and time-consuming stages of manufacturing. Rather than trying to speed it up, Tesla apparently is asking a far more radical question. What if you don't need a paint shop at all? According to Tesla's patents, the body panels of the Cybercab may be produced with color built directly into the material during the forming process. The color would appear at the moment the panel is created, with no separate painting stages. Notably, the latest production versions of the Cybercab look noticeably glossier than the early matte prototypes, hinting that the idea is moving toward reality. If that happens, the implications will be enormous. Paint shops take up massive amounts of floor space, consume huge quantities of energy, and add cost and complexity to every car that rolls off the line. Eliminating that entire stage doesn't just save time, it fundamentally simplifies manufacturing and reduces the cost of the factory itself. Everything described in this video isn't science fiction or some distant future. This is a manufacturing strategy that's unfolding right now, and if you're interested in watching how global industry is changing in real time, subscribe to the channel and hit like. The best is yet to come.